Hello, everyone, and welcome to this session where we'll explore how a media and entertainment customer is modernizing its data architecture using cloud services. If you're new to cloud computing or data architecture, don't worry, I'll explain everything in detail. By the end of this video, you'll have a solid understanding of how data flows in a cloud environment, how modern tools like AWS and Snowflake are used, and why this is important for businesses. Let's get started. So let's start with the business context. The media and entertainment customer wants to modernize its data architecture. But what does that mean? So in simple terms, they want to move away from old complex systems and use simpler, more efficient cloud services. But why is this important? Well, in today's world, data is one of the most valuable assets for any business. However, if the data is scattered across different systems, it becomes hard to access, analyze, and use effectively. That's why the customer wants to create a single source of truth, a central place where all the data is stored and managed. This will help different teams access and use the data more easily, and it will also allow for better data sharing across the organization. Next, let's talk about the legacy state. So this is the old system that the customer is currently using. The legacy system has several challenges that make it difficult to manage data effectively. Let's break down these challenges. First, complex data pipelines. So the customer is using AWS Glue, which is a tool for moving and transforming data. However, the setup is complicated. Imagine trying to build a highway system with too many twists and turns. It becomes hard to navigate. That's what exactly happening. The data pipelines are overly complex, making it difficult to move data from one place to another. Next, there is limited collaboration. Different teams aren't working together effectively because there is no central place to store and share the data. Think of it like a library where books are scattered all over the place. It is hard to find what you need. Similarly, without a unified database, teams struggle to access the data that they need. There is no unified database, so there is no single place where all customer data is stored. This makes it hard to get a complete view of customer interactions. For example, if a customer interacts with the company through multiple channels like social media, email, and in store purchases, it's difficult to track all those interactions in one place. And finally, they have fixed ingestion patterns. The company only has certain ingestion patterns that are supported in the current architecture. So in case a new ingestion pattern or a data source needs to be onboarded, it again takes weeks or even months. So these were the challenges that the customer was currently facing. So in the future state, the customer wants to solve these problems by implementing several key changes. Let's go through them one by one. The first is the customer wants to implement data contracts. So these are nothing but the agreements between data producers, the team that create the data, and data consumers, the teams that use the data. So data contracts define how data should be structured, formatted, and shared. Think of it like a contract between a landlord and a tenant. It sets clear rules for how things should work. Data contracts ensure that the data is of high quality and trusted, and they help prevent misunderstandings between the teams. Then they want to implement core data products. So these are the data sets that are designed by the platform team in consultation with the business. Think of core data products as the foundation of the house. They provide essential structure that everything else is built on. These data sets are carefully curated and optimized for use across the organization. And then there are derived data products. So these are the data sets that are created from core data but tailored for specific business needs. For example, the marketing team might create a derived data set that focuses on customer behavior, while the finance team might create a data set that focuses on revenue. Derived data products allow teams to customize the data to meet their specific needs. And finally, the customer wants to have improved collaboration across teams. So the customer wants to improve collaboration between the engineering and governance teams. They're using tools like Alation for metadata management and Open Telemetry for data observability. Metadata management is like creating an index for a library. It helps teams find the data they need quickly. Data observability is like having a dashboard in your car. So it gives you real time information about how the system is performing. So with that context being set, let's look at the legacy architecture in more detail. So in the old system, data comes in from different sources like Oracle, MariaDB, and streaming sources. These sources could be anything from customer databases to real-time data feeds from social media. The data is extracted using AWS Glue, which is a tool for moving and transforming data. So AWS Glue is like a conveyor belt that takes data from one place and moves it to another place. However, in the legacy system, this process is complicated and it involves custom Python scripts. So once the data is extracted, it is loaded into an S3 bucket. So S3 is the cloud storage service provided by AWS. Think of it as a giant storage locker in the cloud. The data is stored in different folders within the S3 bucket depending on its source. From there, the data is transformed and moved into different layers. So as you can see, we have layers like rawest, syndicated, and curated. Snowflake is being used as a cloud-based data warehouse. So the rawest layer is where the raw data is stored. The syndicated layer is where the data is cleaned, and the gold layer is where the data is fully aggregated or summarized for the business use. So this is how the legacy architecture looked like. Let's look at the future state architecture. In the future state, the process is more streamlined and efficient. Let's break it down step by step. Let me zoom in a bit. So for the batch data sources, for data that comes in batches like daily sales data, the process starts with DMS, which is Amazon's data migration service, which extracts the data from sources like Oracle, MariaDB, etc. So the data is then sent to Kinesis stream, which is like a river of data flowing in real time. From there, it goes through a Lambda function, which is like a piece of code that processes the data. And finally, the data is sent to Kinesis Firehose, which loads the data into an S3 bucket. For streaming sources, for real-time data streaming like social media feeds, the process is similar, but it skips the DMS step. So that the data goes directly from the source to Kinesis stream, then to Lambda, and finally into S3. So once the data is in S3, it's loaded into Snowflake using Snowpipe, as you can see it here, which is a tool for continuous data loading. Snowpipe automatically loads the new data into Snowflake as soon as it arrives in S3 with a latency of just 1 minute. So the data then goes through different layers of transformation using dbt and UC4 as the scheduler. So dbt is used to clean, deduplicate, and version the data, while UC4 ensures the transformations happen on a schedule. So this is how the future architecture looks like. Now let's dive into the detailed data model. So data is organized into different layers known as the Medallion architecture. Think of it Think of this architecture like a factory assembly line where raw materials data are refined step by step until they become a finished product. So we have the landing layer. So this is where raw data first arrives, like the receiving dock of a factory, where raw materials are unloaded. The data here is in its original form, straight from the source. Next, we have the bronze layer. Here the data is cleaned and flattened. Cleaning means removing errors or inconsistencies, and flattening means converting complex data structures like JSON into simpler format. This is like taking raw materials and cleaning them up so that they are ready for processing. Next, we have the silver layer. So here the data is deduped and versioned. Deduped or deduplication means removing duplicate records, and versioning means keeping track of changes to the data over time. This is like refining the materials further to ensure they are of high quality. And then we have the gold layer. So this is the final layer where data is fully curated and ready for business use. It's like the finished product coming off the assembly line, ready to be shipped to the customers. So this is how the detailed data model works in action. So data is organized through your medallion layer system. These different stages represent the different levels of data curation: landing, bronze, silver, and gold. UC4 is used as a scheduler, and DBT is used to perform the transformations. So in terms of how the flow looks like from bronze to silver to gold, so data based on batch ingestion pattern or streaming ingestion pattern will be loaded into Snowflake landing layer using Snowpipe. Then DBT models are generated using Python scripts to load the data into bronze. The conceptual data models and the entity relation diagrams are developed by the data modelers, and then DBT models are created using the Python scripts. And finally, the curation happens in the gold layer. So, using DBT, summarizations and aggregations are done on the gold layer. So, the client or the customer here implemented data contracts. What are data contracts? So data contract is an agreement between the data producer, the teams that create the data, and data consumers, the teams that use the data. Think of it like a contract between a landlord and a tenant. It sets clear rules for how things should work. Data contracts define the structure of the data, what fields are included, the format of the data, how the data is stored, and the rules for exchanging the data, how the data should be shared between the teams. Data contracts ensure that the data is of high quality and trusted. They have also helped scale the system as the business grows. For example, if a new team wants to use the data, they can refer to the data contract to understand how to access and use it. Conclusion: to wrap up, the media and entertainment customer is modernizing its data architecture using cloud services like AWS and Snowflake. By creating a single source of truth and standardizing data ingestion and using tools like dbt and data contracts, they're making their data more accessible, reliable, and useful for the entire organization. If you're new to cloud computing, I hope this video helped you understand how data flows in a modern cloud environment. Thanks for watching, and I'll see you in the next session. Thank you.